Hello dear students, this is Devang Shah from LG Institute of Engineering and Technology. Again, we are learning the same subject, the basic electrical engineering, right? In our previous lecture, we have discussed about Kirchhoff laws, then some of the basic parameters or the components of electrical circuit like resistance, inductor, and capacitor. Now, in our today's session, we are going to learn about theorems. Those theorems are named as circuit theorems. Now, why we need to understand, why we need to learn this theorem? Because once you design any circuit, right, then you have to analyze it. So in our previous lecture we have discussed about our main goal, our main aim of learning this subject is to design an electrical circuit or electronic circuit. Now in this particular design, once you design any electrical circuit, you have to solve it, right? You have to analyze it. So let's say there is a big network where there are so many number of resistors are connected, some voltage source and current sources are connected. So what you need to do, from so many resistors, let's say you want to find a voltage drop or current flowing through a particular resistor, how can you find, right? So this describe a different kinds of methods, a way of solving the circuit design. That's why we are using electrical or circuit theorems, right? So if first we go for a kind of basic of network, and we have to learn some of the important parameters. Let's say we talk about the first parameter. The basic part is called circuit. When current flows the closed path, or a path through which current flows or intend to flow, is defined as a circuit. So if we define here, now this particular part is a circuit. Right, you can see here there are four resistors are connected with a 1 voltage source. Right, the complete this design we consider as a circuit where current must flow the closed path. Next, we need to understand uh, what is the node, right? So a point where two or more than two elements are connected, or in another sense you can also consider three or more than three branches are connected at a particular point. That point we define either as a node or junction. So you can define here, this is the location of node or junction at this particular electrical circuit. Now next part is a branch, where a part of the circuit or a network which lies between the two node junction points. The branch may have one element or more elements in a series, right? So if you define here branch, you can see here there are three branches where here the individual elements are connected. Now our next important term is called the loop. Now you can consider this as a loop or mesh is nothing but a closed path in a network is defined as a loop. So ultimately the current must follow the closed path. You can either consider as a loop, as a whole, you can consider as a circuits, right? Now what kind of different sources you have to connect with the circuit. Let's say some of the DC voltage source and current source you can define here. So you can see here there are symbols of the DC voltage source and DC current source, right? Same way you have a AC voltage and AC current source, where you can see here the symbols of AC voltage source and AC current source, right? Now, again, there are various part of the sources, that some of the sources are independent sources, right? So these independent sources are defined as here as a part of symbol, and some sources are dependent sources. That sources itself depend on some other sources, we can define as a dependent sources. So these are nothing but various components, various elements that can be involved in a circuit design. Now we'll start with our main theorem, which is called a Thevenin theorem, right? So if you look the statement of this Thevenin theorem, where in a linear bilateral or active network. So what do you mean by the linear bilateral and active network? That means the complete circuit we define as a which contains combination of resistors, like in a series combination or a parallel combination, right? So if we go and discuss about the statement, so in a linear bilateral active network, the current flowing through any element can be found by the remaining part of the network by a voltage source VTH in series with the resistor RTH. So what does it mean? Here you have a given network, or it's an active network where it's a combination of resistors which is in a series and parallel, right? Now you select particular resistor where you need to find the voltage drop and current which is flowing through this particular resistor, right? So rest of the resistors and voltage source or current source, right, you have to replace by a single voltage source in series with a single resistance, and that resistance is called the equivalent resistance. In our science it is called the Thevenin resistance, right? So once you are going to solve the complete active network and converting into only two component. One is called Thevenin equivalent voltage, which is defined as a VTH, and another resistance which is called a Thevenin equivalent resistance, which is called a RTH, right? So once you solve the complete network, you can see here the given network is now replaced by in series with VTH and RTH, and then whatever voltage drop at current flowing through that particular resistance, you consider that particular resistance as a load resistance RL, and then you can again connect it, right? So the complete big network now you have solved with the one voltage source and two resistances are in a series, right? So by that way you can find a current flowing through a particular resistance or a voltage drop through a particular resistance using this simplified network, right? So by this particular equivalent circuit, you can see the value of IL. It's very easy to find. From IL is nothing but the VTH divided by RTH plus RL. Simple, if you apply the Ohm's law, you can find the equation, right? Now how we can solve any circuit, or how we can analyze any circuit using this theorems. For that you need to understand, you need to learn, or you have to apply some of the important steps. So there are 4 steps. The step number 1 is that you have to remove RL from terminal A and B. That is called a load resistor, right? So ultimately you have to remove the resistance between terminal A and B. That is your step number 1. So you can see here, this is your step number 1. Then step number 2, once you remove the RL, then complete active network you have to convert into equivalent Thevenin voltage and in series with equivalent Thevenin resistance, right? So my next job is to find the VTH. Now how you're going to find the VTH? By using all the methods like Kirchhoff voltage law, Kirchhoff current law, voltage divider rule, current divider rule, etc. You can apply, and you can find the equivalent voltage source that is considered as a Thevenin voltage source. Now my next job is to find equivalent Thevenin resistance, right? And then the same thing you have to apply, or you have to find RTH by making all voltage sources short and all current sources open. So you have to make a complete big network which is called a purely resistive network, where if you find a voltage source you make it 0, if you find a current source you make it 0, right? So complete network is now made up from the series and parallel combination of resistance. So by that way you can find the equivalent value of Thevenin resistance. And finally you have to connect RL. So once you connect RL, then you can find the circuit current by applying this equation, by using this equation. IL is equal to VTH divided by RTH plus RL, right? Now let's apply all those 4 steps in our one of the example. So we define one of the example here. Let's say my example number 1, which is using the Thevenin theorem, find the current through the 20 ohm resistance. Now this is the circuit where you have to find the current which is passing through 20 ohm resistance. So now 20 ohm resistance I consider as my load resistor. So my first step is that I have to remove RL. So once I am going to remove RL, that means 20 ohm resistance I have to remove from the network, and rest of the part my job is to find VTH and RTH, right? So equivalent voltage and equivalent resistance of rest of the active network once I remove the RL, right? So my next step number 2 is to find VTH. So once you find the VTH, you can see here that is the network. So ultimately VTH is nothing but the voltage drop across 10 ohm resistance which is given between terminal C and D, right? So my next job is to find the voltage drop across 10 ohm resistance. Next, to find the voltage drop across 10 ohm resistance, I have to find the current which is passing through 10 ohm resistance, right? So the complete rest of the network I have to solve and find the total resistance of this rest of the network. So once I'm going to find the total resistance by using this equation, like RT is the total resistance, right? So RT, where you can see from 20-volt source, you can find the total resistance from this point. You can see from the 20 volt, 10 and 10, these two resistances, I mean, are in parallel in series with 10 ohm resistance once you look from the 20 volt source, right? So ultimately your total resistance would be 16.67 ohm, and once you find the total current of the circuit, I is equal to 20 volt divided by 16.67 ohm, so it's a 1.2 ampere, right? So that's the current. Now that current I have to find which is passing through number G to E, and then from E to C and D, right? So ultimately I have to find and I have to apply the current divider rule, where ICD is nothing but 1.2, that is my total circuit current, multiplied by 10 divided by 10 plus 10 plus 10, which is a current divider rule. So from that I can find the current which is passing through 10 ohm resistance, or the resistance between terminal C and D is 0.4 ampere. Now to find VOC or VTH, I have to multiply 10 multiplied by 0.4 ampere current, so that would be a 4 volt. So here my value of VTH is 4 volt, just remember this. Next we have to find the RTH. Now that RTH is step number 3, where you need to find RTH where all voltage sources you make it short. Once you make it short, it becomes 0. So in this particular network, you can see 20 volt, you have to make it short, right? So from this side you can find your RTH, then 10 and 10 ohm resistance are in parallel in series with the 10, and again in parallel with 10, and again in series with 10. So you can see find the RTH, and you can find this particular equation where RTH is equal to 10 in parallel with 10 plus in uh, plus 10, that means in the series with the 10, again in parallel with 10 plus series with the 10. So once you solve this network, you can find total RTH would be 16 ohm. So now you have found VTH and RTH, make it in a series, right? VTH in series with the RTH, so 4 volt VTH in series with a 16 ohm of resistance. So you can find this network. Now you use the step number 4, which is you now connect the RL. Once you connect the RL, you can easily find the load current IL, which is simply find the using this equation. IL is equal to VTH divided by RTH plus RL. You can current which is passing through 20 ohm resistance is 0.11 ampere. Now by this way you can apply all this step number 1 to 4, and you can solve the any given network using the Thevenin theorems, right? The straight away we can also consider our next example, which is straightforward. Here we have taken two voltage sources, 10 volt and 20 volt, with the three resistances 10 ohm, and RL is here given a 4 ohm, right? So here they have already given the resistance between terminal A and B is the 4 volt, so RL is the 4 volt. So my first job, I have to remove the RL. That's my step number 1, right? So I'm going to remove the RL. So now this is my network, and from this network my job is to find VTH, which is a voltage drop across terminal A and B. So either you can find from this side or this side, right? So let's say we can find right side, so where is the 20 volt minus 10 into I, and that I is nothing but the current which is passing through the overall circuit. So once you apply the KVL and you use this equation, 10 is equal to 10 I plus 10 I plus 20. So from this you can be able to find the current, total current I is equal to minus 0.5 ampere. Now the same thing if you apply to find VTH, you can see the equation here. VTH is equal to 10 minus 10 into I. So that VTH you can find up to 15 volt, right? So the voltage drop across terminal A and B is nothing but the 15 volt, right? Same way, step number 3, we have to find RTH. So make it two voltage sources short. Once you make it two voltage sources short, that means two resistances 10 ohm and 10 ohm are in parallel with each other. So RTH is equal to 10 in parallel with 10. You will find a 5 volt, right? So ultimately here, now you found VTH, RTH, right? So make it equivalent circuit where VTH in series with the RTH, so 5 volt in series with the 5 ohm resistance. Now you connect your RL. So once you connect your RL, it's a step number 4, you will find total current IL which is passing through RL is 15 divided by, that is no, VTH divided by RTH plus RH. So 15 divided by 5 plus 40. So ultimately your IL current is nothing but 0.33 ampere. So by this way you can solve, you can apply Thevenin theorems and you can solve the examples, right? Thank you very much, dear students. If you have any doubt, you can straight away ask me in a comment box. Thank you very much.